going live. You're live, it says. So, welcome everybody to the second virtual event of the Northumberland Dark Sky Festival. Tonight we are introducing you to Deep Sky Astrophotography with Chris Duffy, the Chairperson of Sunderland Astronomical Society and the Director of Battlesteads Observatory. Before we get started, what I'd like to do is just give you a brief introduction to what we're all about, what the festival is all about, and how we expect everyone to behave tonight. So I will just share my screen to make sure I can make that happen. Good stuff. Right, so as I said, welcome. I'm Roy Alexander. I'm going to be moderating tonight and also dealing with questions in the chat. So if you've got questions for Chris tonight, then do fire them at me in the YouTube chat. I'm the Learning Director of Battlesteads Observatory and the Director of Astrophotography CIC. And this year, because of the pandemic, our festival is entirely online, which means that actually we've been able to organise some really fantastic international speakers, but obviously next year, we hope to see you here under our wonderful, inspirational Northumberland dark skies. Very quickly, the festival is a collaboration between all the observatories in Northumberland. That's the Calibration Observatory there that you probably recognise, the Stonehoff Pavilion at the Stonehoff Observatory there. This is the view from the Twice Brewed Observatory, and finally our observatory that we run, the Battlesteads Observatory there. All wonderful places, and we hope you'll be able to visit us just as soon as we're allowed to start traveling around the UK. So as I mentioned, I'm going to be moderating and hosting the YouTube chat in the background while Chris does his talk. Please do ask questions, although if you can make a note of them and ask them at the end, that would be better, just to make sure that we don't miss anybody. And obviously make sure that you're kind in your comments, please. From now until, well, tomorrow, the CPRE is asking us all in the UK to do a star count, and I'd like to encourage you to do that. And it just means you get outside on a good clear night, which hopefully we have, or you might have where you are. We don't currently here in Gateshead. And you look at Orion and you look at the four stars in the corners of Orion. Give your eyes 10 to 20 minutes to adjust to the dark, and then count those stars that you can see within the Orion constellation. Google up CPRE star count or head to that link there and submit your data. That would be great. Finally, as part of the whole Dark Sky Festival, we're supporting the International Dark Sky Association's mission to preserve and protect the nighttime environment and all the things that go along with that. So if you're interested in getting involved with the IDA, you can join various chapters, you can join them directly, you can donate, you can gift donations and so on. Okay, so that's enough for me. That's us introduced. I am going to stop sharing that window. We still have a couple of people who have gone into the Zoom, so I'll have to shuffle them across to the YouTube. I think, Chris, we're ready to hand over to you. Thank you very much. Over to you, Chris.
Okay, thank you very much, Roy. Yeah, as Roy said, my name's Chris Duffy and I'm an astronomer. I've been doing it for a long, long time. I'm now one of those very lucky people who actually gets paid to do their hobby. I do the Astro Ventures. I do the nights at Battlesteads, or at least some of them, and I also do some astrophotography courses there. I'm just going to start the obvious PowerPoint presentation here, and I hope you can see that. Again, just confirm who I am and what I do for a living. This is a very brief talk for people who maybe are thinking about getting into what we might consider quite a bit of a dark art of deep sky astrophotography. We haven't got enough time to cover everything in great detail, so what I'm going to try and do here is give you a bit of a taster. Just a few of the sort of central points and important things that you might need to know to get right so you can get started. And then once you start to do that, you can then start to learn far more about it as you make your own journey through astrophotography. Once you get into it, it's very addictive, and it can be very rewarding, but very frustrating as well. So what we're going to do tonight, briefly, is I'm going to go through a few of the topics that I feel are important when you're trying to get started. First of all, what do we mean by deep sky? Because that's the title of this particular talk. I'll then briefly touch on the types of telescope that are suitable to do it, and perhaps some that you should avoid. Then I'll talk about what people might call the tripod, or the mount, that the thing you put your telescope on to enable you to take the pictures. And then some important things like how to get focused properly, how to take what we call calibration frames, which are essentially frames of the camera's noise, which can then be subtracted from your noisy image that it will be if it's a long exposure. And at the end, I'm going to try, if we can, and if the technology works, to actually live stack a few images just to show you how it works. So what do we mean by deep sky astrophotography? Astronomers use the word deep sky to describe anything that is outside of the solar system. So it doesn't include the planets or the moon or the sun or the comets. It's the stars, the nebula, the galaxies, all of the stuff that is outside of our solar system. It tends to be faint, which is why it's quite difficult to photograph, and why you need a little bit of specialist equipment to do it. Now, I tend to find that there are a couple of different types of people who get themselves started in astrophotography. There are people like me who have been an astronomer for a long, long time, and then about 9 years ago, I decided to start to take pictures of the things I was looking at the sky. The other people can come from it from the other direction, in that you might be a photographer and know a lot about your cameras and how your camera works, and you now want to kind of start to take pictures of things in the night sky using a telescope or indeed a telephoto lens. The type of telescope that you need for astrophotography tends to be different to the type of telescope that you need for visual astronomy. This is what I take out on an average night when I go to do my astrophotography. And yes, at the lower right-hand side of the screen, that is a hairdryer. Not for me, obviously, but it's good for getting condensation off the lenses. You don't need all of that. I started out with something simple like this. A DSLR camera with an adapter on it, so I could fit it to the telescope, a remote shutter release, and my trusty 8-inch Newtonian telescope on a mount that is computerized and tracks. It's a great visual instrument, and I still own it, but it's not particularly brilliant at astrophotography, but it will get you started if you've got a telescope like this. It's perhaps a little bit too big. Anyway, in 2012, I went out with that equipment to the dark sky site, and I took a few pictures. I think this is the first picture I ever took. It's of a galaxy called NGC891, sometimes nicknamed the Outer Limits Galaxy, because I think a picture of it was used in the titles of that 1960 science fiction program. And I took a few of these pictures. They're very short exposures, about a minute, because I couldn't really get my telescope and get my stars to stay roughly in shape for that long. And indeed, if you look closely at those pictures, you'll see all of my stars are wonky. They're not quite in shape. I haven't been able to expose the image quite long enough to get a lot of color in them. But for me, I was kind of over the moon. And to get these pictures, you don't need expensive, well, relatively expensive equipment. It's all a relative term, I think, with astronomy. All astronomy equipment tends to be costly, but it doesn't have to cost the absolute earth. So what types of telescope are suitable if you're going to start out? Now, if you've already got a telescope and a camera, I would say that's the one you use. But if you're thinking about getting a telescope to start with astrophotography, try to avoid really big telescopes and ones that have really long focal lengths. That's the length, the focal length of the image. That's how long the focus of the telescope is, because they tend to be more difficult to take pictures with. Those of you who are photographers might understand the concept of focal ratios and apertures. F5, the lower the number, we call these fast telescopes. And it's a bit like with a camera. You know, when you open the lens wide, you don't need as long as an exposure, but you've got to be more careful with your focus. So astronomical telescopes tend to have focal ratios of around about f6 or less. The more than that, they're more suited to taking pictures of really bright objects, like the moon and the planets, for instance. So these three telescopes you can see there, the Newtonian reflector, which is the one on the left of the screen, is described as f5. The one in the middle is about f6, and they're both highly suited to astrophotography. The one on the right-hand side of the screen, the one that looks shorter than the others and is actually physically shorter than the others, has a very long focal length. It has a focal length of about 2 meters and is f10, and therefore would be described as slower. And in actual fact, to get the same amount of light to hit your camera from the one on the left to the one on the right, the one on the left would only need a quarter of the length of the exposure time, because it's got a much shorter focal length. It's a little bit different when you think about telescopes for visual use, because for visual use, you want the biggest one you can get with the biggest and widest aperture so you can see more. But our eyes don't work like camera sensors, and therefore, you know, the criteria is a little bit different. So if you're starting out, you want to get a fairly small telescope with a fairly small focal ratio. So if you're buying one and you're talking to your dealer, ask them what the focal ratio is. Wants to be about f5 or f6. Some of the very, very advanced astro telescopes have even shorter focal ratios than that, f3, f2.5, but they are very difficult to use and not really. You're better off sticking with f5 or f6 if you're just starting out. Now, you've got to mount it on something. You can't hand hold a telescope with a camera on the end and expect to get a long exposure image. So you need to put it on a tripod. And if you're going to take pictures of deep sky objects, because they are faint, you're going to have to do exposures of several seconds as a minimum. Most experienced astrophotographers use exposures of several minutes. So to do that, you have to have a mount that will track the sky. And I'll come on to that a bit more. I'll talk a bit more about mounts in a moment. Cameras, as I said, a lot of people start with DSLRs. You don't need a sophisticated one. A lot of the additional features that make some DSLRs extremely expensive are really just designed for video and daytime photography and that kind of thing. You can do very, very good astrophotography with a good second-hand, bottom of the range Canon or Nikon, and it's always worthwhile considering getting one of those. You will need an adapter. You can see there on the screen there's a thing called a T-ring, and there's another little nose piece called a T-adapter that enables you to then mount it into your telescope, the same place you would put your eyepiece. And in effect, what happens is the telescope itself becomes a big telephoto lens to enable you to capture your pictures. If you haven't got the kind of camera that you can take the lenses off and then use the telescope as the lens, you can still do some limited deep sky astrophotography. You use a type of photography called afocal, where you put the camera lens up against the eyepiece of the telescope. So you get your object, you get it in focus, you then put the camera lens up against that. Again, you're going to need a fairly long exposure for a fairly dim item, so you need a kind of camera that will do 20 seconds or something like that. I would have said in the past that mobile phones are no good for that, but there are a few new models of mobile phone that are allowing long exposure photography. Although I will be, to be honest and say that they're not quite there yet. If you're serious about doing astrophotography, you probably at least need something like a DSLR camera. Or if you're feeling flush, you can go for these Astro cameras. They're not really the realm of the beginner. They cost £150 upwards. And for £150, you get a very basic one that isn't cooled and isn't really suited to long exposures. If you want one with a chip the same size as a DSLR, then you're going to be paying above £1,000 for it. So as a beginner, you probably might consider a second-hand DSLR first, because these are complicated to use. The other thing about these is they all require you to have your laptop with you when you use them, because they have no intelligence built into them like a camera has. They can't show you the image. They can't take the image without your computer, without your laptop. You also need a remote shutter release. Because with long exposure, you can't press the shutter with your finger. You will make the whole thing shake and you'll get a shaky image. So a remote shutter release is good. This one's called an intervalometer, and it allows you to program a number of shutter releases in, so it will automatically do them without you having to touch anything. But you can just use an ordinary shutter release. If you haven't got one of them, then you might want to use any kind of delay timer that the camera might have. So you can press the shutter and step back, and hopefully by the time the shutter actually opens following the delay, your telescope will have stopped shaking. And certainly with mobile phones, if you're trying it with a mobile phone, a lot of them these days, you can activate the shutter with your voice. So you can be standing away from it and you can tell it to start to take the picture, which is a good adage. But what you can't do is just press the shutter with your finger, because you will make everything shake and you will get a very blurry shot. Coming back to mounts, I briefly touched on them before. You get two types in astronomy. You get what most astronomers probably use, which is what's called an equatorial mount. It's designed to move in the same way the stars move across the sky. One of the difficulties we have in trying to take pictures of faint objects out there is the world's spinning. So the objects move past us. So you need to be tracking them to keep them in the field of view. When I started out in astronomy in the early 1970s, there were no computers in astronomy, and therefore the only motorized mounts you could get were the equatorial ones, where you could attach a very simple clockwork motor to the right ascension axis, as it's called, which is the axis motion that follows the star. Computerized altazimuth mounts. Now, an altazimuth one is a simple one that goes from left to right and up and down, and it arranges the tracking of the sky by moving either to the right and to the left, or to the left and then up a bit, and it's usually moving to the right, by the way. Right and up a bit, right and up a bit, or right and down a bit if the object has passed the meridian. So they are less suited for astrophotography, and this is why it's a little bit of a difficult slide this to get your head around. But I just want you to sort of notice on the top three pictures the little two stars that you can see in the top left-hand corner, and you can see, as the night goes on and the object moves around the sky, the image you see in the telescope doesn't change, because the equatorial amount follows it in the arc exactly the same way. So the image stays in exactly the same orientation in the picture. Whereas the bottom one with the altazimuth mount, it's rotating, so the picture stays the same, but you can see those two little stars, they only briefly appear in the middle picture. Now, what that means is it means the object is slowly rotating. And if your exposure is too long, then the camera will capture that rotation and blur the image. Therefore, you can do it with an altazimuth mount, but your exposures are restricted to quite short ones. And how short will very much depend on the camera you're using and the focal length of the telescope. So if you can, go for an equatorial mount. And of course, there's the first learning curve, because equatorial mounts require you to line them up with the celestial pole. We in the northern hemisphere are quite lucky because we have a star at the celestial pole, Polaris. So the first thing you need to do is find out how to find Polaris. It's not that bright. Up at Battlesteads, when we do our public nights and I point out Polaris to people who are there, a lot of them are quite surprised, because in popular culture and popular myth, the North Star is supposedly a very bright star, and it isn't. It's not famous for its brightness, it's famous because of its position in the sky. It doesn't appear to move. And looking at that photograph you can see on this slide, you'll see if you just put a camera, an untracking camera, on a tripod and take a long exposure photograph, you will get these star trails, because the stars are moving as the Earth turns. But the one in the middle, which is the North Star, has hardly moved at all. It's not exactly on the celestial pole, it's a little bit off. And part of the learning curve of using an equatorial mount is learning how to accurately line it up with that. And there are lots of apps and lots of methods of doing it. And the more sophisticated equatorial mounts usually give you a little telescope running through the center of the mount itself that you look through, and you can line up the pole star. When you're taking your pictures, one of the hardest things to get right, I think, is focus. And it's one of the worst things to get wrong, because you can't really repair it. You can stretch an underexposed image, or you can kind of dim down a little bit, a slightly overexposed one. If your stars are slightly out of shape and wonky, apps like Photoshop and Lightroom can actually fix that for you. But I haven't yet come across any kind of app or program on a computer that can fix an out of focus photograph. So if you're going to focus, when you focus your image, you obviously can't focus on your deep sky object, so your nebula or your galaxy, because they're just too faint. So what we do is we focus on a star, the nearest bright star to that object, get our telescope in focus and then move it. Trying to do that just by looking at the camera screen, be it the screen on a laptop or the screen on the back of your camera, is very, very difficult, if not impossible. So most astronomers use these things called focusing masks. The one on the left with the 3 holes in it is the old-fashioned one. That's called a Hartmann mask. And when you're out of focus, you'll see 3 stars. And as you move your telescope into focus, those 3 stars will merge into one. It's better than nothing, but the one on the right, which has all the lines and angles on it, that's called a Bartinov mask. And this is the latest innovation. They've been around a few years now, but this is what most astronomers use to focus their cameras in their telescopes. And what happens is it creates a diffraction spike pattern. And what you do is you adjust the focus until the center diffraction spike runs straight through the center of the star, as you can see there from the pictures on the left-hand side of the screen, the 3 of them out of focus and then in focus. What I have to say is it never looks like that. The picture on the right is what it actually looks like when you're looking through your own telescope or on the camera screen of the telescope. You don't get this clean, sharp lines that the manufacturers of the mask seem to imply that you do. What you usually see is what you see on the right, but it still enables you to get very accurate focus. And it is worthwhile spending some time getting that right before you actually start taking pictures. So you've got your telescope, you've polar aligned it, you've got your camera attached to it, and you want to take a few shots. You've got yourself in focus, and you start taking pictures. Now, what most of us do at this point is, if you're going to take any kind of exposure longer than a few seconds, digital camera sensors start to get rather hot and they get noisy, and therefore we tend to try to keep the exposures as short as we can, but long enough to get some data, and take lots of them, and then we stack them together using software to enable us to get a proper image. And also, by stacking them like that, it helps clean out some of this digital noise. So if you're going to take a picture of a bright object, don't try to take a half-an-hour exposure of it, because I'll guarantee something will go wrong in that half an hour. You know, an aeroplane will fly through the field of view of your scope, or the wind will blow it off a little bit, or something will happen, and you're putting all your eggs in one basket. What you probably do, or most instruments do, is break that up into shorter exposures. If it's a fairly bright object, like Roy was talking about Orion before, the famous Orion Nebula only needs an exposure of a few seconds. But if you do lots of them and stack them together, then it really does improve your image. The other thing astronomers or astrophotographers go on about is things called calibration frames, which can sound a little bit daunting. And they go on about darks and flats and dark flats and bias and all of that kind of stuff. When you're starting out, most of us only took one kind of calibration frame, and it's the most important one, and that's the darks. And what a dark frame is an exact duplicate of the photograph you've just taken, but with the lens cap on. All the settings exactly the same, the exposure time, the ISO setting, or the gain if you're using an astro camera, everything the same, but just of darkness. And what you will capture then is any digital noise that your camera's making. And then the stacking software can take those dark frames and remove that noise from your final image. So you would always take some of them. They are temperature sensitive, so leave yourself a bit of time to take a few darks at the end of your imaging session, because you need to take them on the same night. So we're now kind of looking at stacking images, and they remove, the reason why we do it is to remove digital noise. And by stacking them, you'll get a cleaner image. So you look at an unstacked raw frame on the left, and probably a stack of about 10 to 20 of those frames on the right, and it really cleans up the image. Stacking images doesn't have to be difficult, and it isn't costly, because one of the best applications to do it is free, and it's a piece of software called Deep Sky Stacker. And this is what it looks like. Now, what I'm going to do, I've kind of kept this talk quite brief to give a lot of time for questions from people afterwards. And also, I want to just show you a live example of stacking images. And I'm going to do that now. So if you'll excuse me, what I'll probably have to do is stop the share and then share again, but share my Deep Sky Stacker application. Now, Roy, can you nod? Because yours is the only face
I can see that, Chris. I just want to tell you, Chris, that we have 200 odd people watching. Lots of people are asking questions, and I'm doing a fairly good job of answering them, actually, with my limited knowledge. There are a couple of questions about astrographs versus telescopes and cameras and things like that. So we'll get to those at the end. Angie is saying she's screenshotting a lot of this info, which is great. But Angie, just to let you and everybody else know, this is being recorded. And when we finish this live stream, it will be there on our channel for you to listen back and pause and whatever you want, whenever you need to. But yeah, I can see your Deep Sky screen.
Well, I'm just good, and what we can do, Roy, is I'm going to set it away so people can see what's happening. Yeah. And then it takes a few minutes to do. So while it's doing it, we can maybe have a go at answering some of the questions.
Good, fine. Yeah, far away. You're in charge.
So what I'm going to do is, so with Deep Sky Stacker, I've picked a very small number A few pictures I took in 2015 of the Orion Nebula, a very, very well-known subject. Now, actually, on the night, I took about 25 of these images, but that would take too long to stack. So I've just picked at random 5 of them, and I'm going to load them into my Deep Sky Stacker application. I also took a few dark frames as well. And again, I've got 5 of them, and I'm going to load them into there. Now, I'll just, with this application, and there are loads of tutorials on Deep Sky Stacker on YouTube. So once you've loaded it, you can play with that. You don't need to try and remember. You do have to check them all to make sure they're all going to be apt. And if you just come down the bottom of the screen, you can see there, I've got light frames and there, and also dark frames at the top. Now, I'm just going to remove them because I've just realized it's loaded. I'm just going to clear the list and start again. I'm going to open my picture files because while I was talking to Roy, I clicked on the wrong button. And I should have clicked on dark files.
Yeah.
So it
Chris,
would load dark.
Someone has asked a question I can't answer.
Yeah.
Stack, do you always use raw images to stack?
It is best. You can stack TIFF files and some applications, some astro captures use PNG files. They can also be stacked. But yes, I would recommend if you're using a DSLR, always take your images in RAW. And the reason for that is JPEG files in particular are quite lossy, and when you start manipulating them and stacking them, they all tend to deteriorate in quality, whereas raw images don't.
Okay.
Now you can see there you go, all of them are the same, my darks and my lights. I took them in with a Canon 1100, a bottom of the range camera, and they were all 90 seconds each. Some dark.
So that's another good thing to point out to people is you don't need a high-end DSLR.
No, as I said in my talk, quite a lot of the features that make that kind of camera and the new mirrorless ones expensive are usually video speeds, lots of features that are really designed for sports photography and terrestrial photography. Generally speaking, you just don't use them if you're using them for astrophotography. You can pick up a good second-hand astrophotography camera for about £100.
Yeah, you can, if you go to is it MPB or the London Camera Exchange?
Yeah, there are a few
extensive camera.
There's a guy called Cheap Astrophotography who sells DSLRs that have been specially modified for astrophotography.
Oh, well, that's good to know.
And had certain filters removed. It's a little bit beyond this talk, but yes. Anyway, I've done that, so I'm just going to register these pictures, and I'm going to tell it to stack them. But before I do, I'm just going to check how many stars it can see, because you can't alter the sensitivity. So it's just going to do this little run through, and you will see, yeah, it's counting the stars. It needs to see at least 50 to be able to stack the image. And in this, it's saying 187. I can increase the sensitivity by moving the slider a bit further to the left. So if I do it at 2% and ask it to do it again, you'll see it will see far more stars.
Yeah. When you did that, it really slowed down your computer and you went all jiggery for about a second and your speech went, just while it's doing that, we've got some other questions. Any advice on how to tame an EQ wedge other than getting rid of it? From Fabio.
Okay, well, for everybody, an EQ wedge is a kind of a wedge you can put in the base of an altazimuth mount to turn it into an equatorial mount, because what you're doing is you're raising the angle of the side to side motion so that matches the RA.
I see. I've always wondered what that is. I've learned something. Thank you, Chris.
You're welcome.
Anyway,
I'm going to set this away stacking. It's only 7.5 minutes. Normally
7.5 minutes. Well, there's 5 other questions I need to ask you, Chris, from the audience.
No, it's only 7.5 minutes of stacking software. And as I said, I'm just going to it's going to do that, and I'm just going to set it away. Now what it's doing is it's going to load all of the dark frames and create a map, what it calls a master dark, which is an average of the of all the dark, so it can subtract that from the image, and then it will stack the other frames. It won't take long because it's only 5. But yes, well, so coming back to the wedge, they can be useful, but it really depends. If you're buying a wedge for a big, expensive Celestron C mount, which is a big, chunky mount anyway, then the wedge may work okay. But you're talking about £300 from Celestron just to buy the wedge. Okay. And in my opinion, that money would be better invested in a new Equatorial mount.
Yeah.
But in the lighter weight mounts, they will help, but they're not. I've not seen any that do it really well yet.
If you put a wedge on an Altaz mount, will you still get that rotation of the image as it tracks across the sky?
No, because the image, the Altaz, instead of doing that, it will do that.
All right. Okay. So when you're doing that and you put your Altaz on it, you set the alt at 0, so it just tracks across on the wedge on that.
It's because of where we live.
I know. I get that.
If we lived on the North Pole, or we lived on the equator, then we would all use Altaz mounts because that's the way the stars would travel around the sky. But because we're somewhere in between, we need the Equatorial mount. So you can, there are a number of people. The wedges that you will use, particularly if you have a manual mount, it means you only need turn 1 fine-tuning adjustment to keep the thing in target rather than 2. But a motorized wedge, I've yet to see one that works very well.
Okay, so I have a question here which I'm going to try and, there's 3 separate questions, but it all seems to be the same kind of question, which is, so this is John, and John Eikenbury, who has a DSLR camera with a good quality 500mm lens. He's been thinking about getting an astrograph, but they're all about 2 to 250mm. Should he just stick to the good go-to mount in his lens, or is there any significant benefit of going to the 250mm, which is half the focal length on the astrograph?
A lot of camera lenses are as good as telescopes. In fact, a lot of them are better, but they tend to be very expensive. You want to buy a top of the range 300mm. Or 400mm telephoto lens, it will cost you several £1,000s. The telescope behind me that you could see when I'm not sharing the screen is, and I'll show it in a minute, is a 360mm focal length telescope that costs about £400. So the small telescope can be cheaper. If you already own the lens, I wouldn't probably buy a telescope of that same focal length.
Yeah, that makes sense. If you've got the lens, why bother? You've just reminded me of this.
Maybe buy a bigger telescope. Well, that's the telescope I've got behind me.
Well, that's what you've reminded me of. I remember because I was looking at the possibility of kind of zoom lenses for this Sony here. And someone's asking about full frame and mirrorless, so I'll get to you on that as well.
Yeah, we will.
When I was looking at equivalent, this is a 360mm Williams Optic Zenith Star 61 to 8.
Yeah, that's the one that's behind me.
Yeah, and the price of that compared to the equivalent lens, I mean, that's £500, but that's peanuts compared to the equivalent lens for the camera. So I think that's a bit of a no-brainer. If you haven't got the lens, buy the telescope. But if you've got the lens, go for it. I mean, a 500mm lens, that sounds excellent.
Right. And you can get a lot, and it'll be lighter than a telescope. So you can go for, there's a type of range of mount called a Star Adventurer, designed for cameras and lenses. It's a bit more lightweight, and they're very good. Anyway, just while I'm doing here, you can see my stacked image. It doesn't look much when it comes out of the stack. And if you can see this thing at the bottom, this is the light curve, and these are where my data are. Now, all I'm going to do is I'm just going to slide this data along the curve and line up the colors. And this is on the hoof, so it's probably going to look, but we'll give it a go. So I'm just going to kind of brighten it up a bit there. And you can see my image is brightening up. I'm just going to push the, that perhaps the other way a little bit.
I just wanted to interrupt and tell all the people in the live chat I am going to get to your questions. There's now about 7 or 8 questions outstanding. However, there's also quite a lot of cracking little experts in the chat. So a lot of people there's a good conversation going on and people are answering each other's questions, which is really good.
Yeah,
I will cover them.
What I envisage this to be more of a forum.
Oh, look at that.
Than me telling. I mean, I have a particular way of working. It's not necessarily the only way. I don't profess to be the best astrophotographer in the world. I try to do it with relatively modest priced equipment, but that's still expensive in a lot of people's views. So you can see I've stretched it a little bit. Let's put a bit of color into it.
It's great seeing the picture grow and develop and change as each process is applied. That's fantastic.
Now you can see at 90 seconds, I've blown out the center of this nebula because it's too bright.
It is. You can't see the trapezium, can you?
No. So what a lot of astronomers will do is they will take 2 sets of images. They might do some of like these ones here about 90 seconds, and they might do a set of 20-second ones. Stack them separately and end up with 2 separate images.
Yeah.
One where you can see the inner core detail and the other way you can see the outer detail. And if you use something like Photoshop or Lightroom, you can combine those 2 images to get the kind of image that you see on the internet.
Yeah. We have a couple of people asking about filters, and I will get to those questions. Don't worry about that. I will get to those questions. But also, I just want to tell everybody that at 8:30 tonight, so we're going to finish this stream at about 8 o'clock, and then me and Chris are going to have a break in about 8:30. On this same channel, but in a different live stream, we're going to do an advanced, like a masterclass, which will be a bit more chatty and a bit more asking questions. So do come back for that. Even if you're a beginner, even if you're looking at this and thinking that, you know, even this is quite a lot to take on, do come back for the second one at 8:30, and I'll post the link to that in the chat as well.
I mean, when we do this kind of thing, as Roy, you will know, when we do this kind of thing at the observatory, the course lasts all day.
It does, yeah.
Just because there's a lot to take in. And what we're trying to do tonight is just give you a little snapshot. So there's my final image stacked. I'm just going to save it. And I'm going to save it in there. And just call it M42, because that's what it is, Messier number 42. Save it on that one.
Yeah, I've just found it, Deep Sky Astrophotography Masterclass. So I'll post the link to that in.
Yeah, that would be good. I go into in-depth in a few things. What I'm going to try and do with the second talk is kind of give the 4 or 5 things that I started doing since I started that few things that I moved up to, the 5 things that have greatly improved my images. Now, I'm going to stop this share for a minute.
There's a couple of people, Chris, who have been doing astrophotography for some time who are saying they're picking up some really good tips here from you. So there's some really good positive feedback.
Mm-hmm. Yeah. So did you want to ask any more questions, Roy?
Yeah, sure. So someone's asking about Mac, on doing it on a Mac. Someone else has basically said, well, just install VirtualBox and run Windows 10 as an app on your Mac. But did you know of, or do you have any Mac deep sky stacking programs?
It is a one of those things. It's a bit like cameras. You know, if you talk about DSLRs, if you're going to buy one for astrophotography, I would normally say buy a Canon. Not because Canons are the best cameras, they're probably not, but most of the software has been developed for them. Most of the free Astro software works seamlessly with Canon. And most of it also seems to have been written for Windows.
Yeah.
There are a few apps that will run in max, but they tend to cost money.
Yeah, so I think your answer there is you know, buy yourself a cheap little Windows or run a Windows 10 app on VirtualBox. Quick question, yes or no, for the dark images that you've taken, Chris, do you run them at the same time as your exposures or not?
Yes, they're temperature sensitive.
Yeah.
So unless you have a sophisticated tech-cooled astro camera where you can actually tell it what temperature to keep the sensor at, then you can have the same temperature. So the only way you can really do that with an ordinary camera or a DSLR is to take them at the same time on the same night. So do your run of your imaging and then immediately after do the run of your darks. Now the darks are with the shutter closed, so the camera doesn't even need to be on your telescope. So what I would do when I'm using my DSLR is once I've done my images, I will then I'll then take some darks. I'll just take the camera off there, put the lens cap, put the cap on it, and leave it on my table and let it take darks while I'm either putting away all the other gear or whatever. So that they don't have to engross on them, but they do have to be at the same temperature so the noise matches.
Yeah, so same temperature, very important, and same exposure as well. Any opinions on the differences between full frame sensors or not?
Well, it affects your field of view. So full frame sensor will give you a bigger field of view because it's a bigger sensor. So how big the object is or how much of it you can get in your camera depends on two things: the size of the sensor and the focal length of the telescope you're using. And if you're using exactly so the full frame camera will give you a bigger field of view. That can be a plus if you're trying to photograph something that's really big and you want to fit it in, like the Andromeda Galaxy, for instance. But it can be a minus if you're trying to photograph something small, like a little galaxy or the Ring Nebula or something like that.
Is that because of cropping? Because I was reading somewhere about bird watching that people often use the crop sensor because you can crop a zoomed image better. Is that the same with astrophotography?
Yes, you can. I mean, you can crop a zoomed image better because you don't have to crop it so much.
Okay.
Whereas if you've got a full frame, you're probably cropping a lot if you want to make it big. The other thing, of course, is with a full frame camera, your individual images, your raw image file size is going to be a lot bigger.
Yeah. Okay. So next question was, actually, I can answer this one. Lots of questions about focus, and I've been paying attention. Some people came to this a bit late though, so they might have missed a bit where you talked about batten-off masks. Someone's talking about they've got an old DSLR. Will a batten-off mask work? Yes, it will. And just generally stick a batten-off mask on. And actually, with more and more people having 3D printers out there in the world, more and more people will quite readily print you a 3D batten-off mask.
If you're pretty arty and crafty, you can get templates off the internet and make your own, using
with card and
modeling knife.
Yeah, and that too.
But they're not expensive to buy. You want the size to fit over the front end of your telescope or your camera lens. And they'll cost you between £10 and £20, so they're not enormously expensive. By the way,
generally the ones that you buy tend to fit on as well, whereas the ones that you're cutting out of card you have to stick on or.
Well, the other thing is astronomy is a hobby done in the dark and in the cold, and if you make it out of cardboard, it will probably last 1 or 2 sessions.
That's a very good point as well, especially with the moisture and the dew. So someone's asked about DSS using RAW or TIFF, but then someone else has answered that question, so that's really good.
Yeah, you can stack TIFF files in DSS as well.
Someone's answered that. That's really good. There's a chap here called Colin who's Dawson who's been really helpful answering loads of questions, which is great.
Just for filters. When you look at my image there, you'll see these stars have a big cross on them, so they look like Christmas stars.
Yeah.
That's because of the type of telescope I used to take the picture. I used a Newtonian reflector, which has a spider vane, it's called, in the tube to hold the secondary mirror, and that's what creates those diffraction spikes. You wouldn't get that if you're using a lens telescope like the refractor that's behind me. Some people hate them, some people love them. I quite like them. Some people like them so much, even if they're using refractors, they artificially put them on their stars. But
Yeah.
it's one of those, it's just one of those things.
Yeah. So filters. People are talking about filters. Filters on the camera, filters on the telescope, filters on, or just filters generally. Do you have any thoughts on filters, or should we cover
it depends where you are and what you're doing. Every filter you use will filter out some light coming through the telescope and hitting the camera. So you've got to balance that loss of light against why you're using the filter. Now, if you live in a light polluted area, then you can get filters that will filter out some of the light pollution. And they're good to use because it means you can extend the amount of time you take the photograph. And therefore, those filters can be very useful. Also, if you're using a refracting telescope, a telescope with glass, with lenses in it, as the light passes through the lens, it gets distorted at the infrared end of the spectrum. And therefore, it's a good idea to have an infrared filter in front of your camera for that. The good news is all DSLRs have them fitted as standard. So it doesn't make, and most cameras do. It's only when you get into the specialist astro cameras where they may leave that filter out because some astronomers want to use specialist things, in which case you've then got to make sure you put a filter into it if you're using a particular type of telescope. I use, generally in light polluted areas, I use a thing called a UHC, which is an ultra high contrast filter. It's really a visual filter meant to help us see nebula, but I find it works great on light pollution. I also have another type of filter called a CLS filter, which stands for city lights suppression, and that's designed for cameras, but I find it doesn't work as well as my UHC. The other thing is, if you're photographing, but I wouldn't use my UHC on a galaxy, for instance, because it cuts out too much of the light. But filters can, that's what I'm saying, it depends what you're trying to photograph. If you're trying to photograph a nebula, then a high range filter can sometimes really good because it'll dampen down the stars and let more of the nebula come through. But if you're trying to photograph something that has the full spectrum of light, like a galaxy, because what a galaxy is lots of stars, then you perhaps don't want to have such an extreme filter in your picture. What you probably start with is what's called a moon and sky glow, which is a subtle filter. It's not for looking at the moon, even though it's got moon written on it. It's actually for looking at other things while the moon's in the sky. Because the other thing I mentioned, when you're trying to photograph deep sky objects, the moon is not your friend. 1 week either side of a full moon, you will find most deep sky astrophotographers don't bother. Because even if you're up in the depths of Northumberland, it's still not dark if the moon's full.
Yeah, that's another reason also why there's not, especially up here in Northumberland, there's not a lot of astrophotography done in May, June and July as well, because the sun barely sets, doesn't it? That's
why our festival is now. Because had we not been locked down by COVID, we would be at the observatory, and there is no moon.
No,
it's round on the near side of the sky near the sun. So that's why we're having the dark. That's why it's now. And that's why there are a lot of them going on around. Because
I believe Will is going to be trying to do a live stream. Will Chung from Twice-Bridge Observatory is going to try and do a live stream, but more towards the end of the week when there's like a partial moon. So that'll be interesting. So Chris, I have another question about Bahtinov masks actually, and then someone's also asked you what's your favourite beer. They're going to buy you a beer as well. So add that at the end.
Well, when you're at Battlesteads, you can buy me one, certainly.
Yes, join us at Battlesteads and buy us a beer when you get there, when we're open.
I like that Kronenberg.
So there's it's another question about Bahtinov masks. So do you have to buy the Bahtinov mask for the camera or the lens or the telescope, or do you buy it for the aperture size and then it can be ubiquitous?
Whatever you're using. If it's too big, it's not going to work, and if it's too small, it's not going to work. Give me a second. I literally will be a second.
Yeah, I mean, what I would say, I can't see the question now. Someone asked about Bahtinov masks. Where is it? It was Sean, S-I-O-N. I think that's Sean. Or Sion, Sean.
Here are 3 Battlesteads masks.
Yeah,
Chris,
I was just talking, you show them that in just 1 second. But I was just going to say that you can generally just go online somewhere and buy the specific Battlesteads mask for your specific lens or telescope. And they're really inexpensive. They're like 10 or 15 quid, 20 quid tops. So it's no biggie to have. If you've got 2 or 3 different optical bits of kit, just over the course of time, buy the ones that fit those specifically. Because as Chris says, when you're out, you're in the dark, it's generally the winter, you're in the cold, you don't want to be kind of faffing about, swapping things about and sellotape and stuff. Just stick with,
that's the one I use for camera lenses. And it would technically also fits over this, like that. And this one I use for a bigger telescope.
Okay.
And he's an intermediate one. This one I bought, now I'm not keen on this one because it blocks out a little bit too much light. You can see it blocks out a lot more light than that one. This style, I'm not keen on it because it just makes the image a bit too dark. Yeah. And I prefer this one.
Cool. Space Bats has asked us this question twice, and I just want to say thank you, Space Bats, for re-asking the question, because I did know I had to ask you a question and I've lost it in the chat. So obviously for people that do have the alt as mounts, and taking into account what you were saying about over time the images being rotated, is Deep Sky Stacker still suitable to stack those images, or do we have to do some kind of wizardry and sorcery?
No, Deep Sky Stacker will stack them. What you will find is that the edge of your image, if I'm just going to share the Deep Sky Stacker screen again. Just give me a second.
Someone else has said the software will align the images.
Yeah. So yes, so let me just come back to this. So if I go to stacking parameters, Deep Sky Stacker, you can see there your different stacking parameters. You've got standard mode, where it will give you a picture the same size as your camera would produce. Or you could do an intersection and it'll only give you the bit where it appears on every image. Or you can do a mosaic where it's all together. But what you'll find is if you're using an altazimuth mount, is because of the rotation, you'll get a lot of raggy edges to your picture that you'll have to crop off because they'll have kind of shifted slightly as it rotates. Because Deep Sky Stacker will de-rotate your picture to line it up so it will stack it. It'll de-rotate it, but that means that kind of the edges of your image, you'll probably need to do a little bit of a crop to get rid of the stacking artifacts that you'll get around the outside of your image. And again, because if you expose for too long, then you'll get blurry images if your actual single exposure picks up that that rotation. If you single exposure, if you expose for too long and it picks up a bit of rotation, you'll get a blurry image. Yeah. But if you keep it down to kind of 20 or 30 seconds, you probably won't notice that. But between your last frame and your first frame, there'll be quite a bit of rotation, but Deep Sky Stacker will kind of put them all right.
That's good. That's good to know. I'm thinking that we're going to wind this up in the next few minutes, unless you've got anything you want to touch upon, Chris. And there are a couple of questions
about a telephoto lens. Let me just see if I can.
Yeah, there was questions about. Well, in fact, someone's answered that one in the chat. Someone's answered chromatic aberration. How do we remove that? Filters or software?
Chromatic aberration is something you get with cheaper telescope and cheaper lenses. If we were doing an advanced class, I would probably just let me show you something here. I just wanted to show that.
Yeah.
Hang on a second. I thought I told it to do from the current slide, but it should.
That's all right.
That's it. Oh, other one there. So that's the Star Adventurer mount, Equatorial mount. Goes on a photographic tripod, but when you're using a telephoto lens, they're about 250 quid. Or you've got this other tracker here, This is the one we were talking about the other day, Roy.
Yeah. They've actually given us, so that's the MSM rotator.
That's right, that's the
MSM rotator tracking mount, and they've given us a code that people can apply if they want to buy one for a discount. And I got to try and remember what that is. I'm not going to never remember that.
It does the same. You line it up. It comes with a little polar scope, and you line it up, and it will then you can then track the sky with it.
Yeah. I'm just digging that code out for people if they want to.
That was just it. Yes. There's a lot to learn, a lot to take in. What were you saying before, Roy? Sorry, before I interrupted you, I thought you were. Did you mention another question?
I think we're done with all of the questions, really.
Well,
filters, we've done that. Chromatic aberration was
yes, that's what we were talking about.
Chromatic aberration.
And that's caused by as telescopes come to focus a lens, and you only get it with lens telescopes, not with Newtonian reflectors, which is one of the reasons I use one of them. Yeah. As it brings the light to focus, because white light is made up of spectrum, it brings the red end of the spectrum to focus at a slightly different place to the blue end of the spectrum and all the colours in between. Now, you can correct it with more expensive telescopes and lenses, such as the one I have behind me, which are called apochromatic telescopes. And it involves using exotic glass and different types of it in the objective end of the telescope. It's hard to get rid of. So if you're doing astrophotography with a cheap telescope, it will be apparent in your stars. You'll see little blue halos around them all. And yes, you can get rid of them with software. You can use fringe killers, as they call. They're really designed as visual filters. You can use them. What I find with them is, though, it tends to take some of the other colours out of your nebula and things. So you've got to be careful how you use them.
And people are talking about chromatic aberration being able to be removed in Lightroom as well.
Yeah, software.
If you use raw images, that works too.
Or you just leave it in. Because one thing I found about astrophotography is that, it's very much personal taste.
Yeah, I remember you and I have had this conversation a lot. So I'm not an astrophotographer. I've picked up a lot of stuff and ideas from all of you. And now that I've got this camera, this Sony A7S II, I am getting into it. And I really like images, deep scale images, where the darkness of space has been set really black. But you and others often point out that that's not what it looks like. And having a lighter, off bluish, dark, blackish, bluish color is more true to life. But then, like you say, it's each to their own. It's what you want to achieve, isn't it? Some people really raise the color saturation on images and use different palettes and things like that. I think time to almost wind this up. I've added the link to the Move, Shoot, Move Rotator Star Tracker, and the code they've given us 10% off until the end of the festival on that. It's a nice little tracker. Lots of thanks from lots of people, Chris. Someone is saying they're trying to build a Dobsonian tracking mount. Can I just use alt-az movement to simulate the equatorial movement, or am I wasting my time trying? John, I'm going to refer you back to Chris's 10 minutes into the presentation, where he showed you that with an alt-az, as you track across the sky, the frame changes and basically your image rotates. So you're not wasting your time, but you're going to be better off with an equatorial.
Yeah, I mean, there's a special wedge, it's called a barn door or something like that, that you get for Dobsonian mounts that fits underneath the Dobsonian. So it's sitting at an angle, and that angle has to match. Now, when you're using a wedge, it's different to an equatorial mount. You kind of got to calculate, because with an equatorial mount, you set the angle to your latitude. So for us, it's 55 degrees.
Yeah.
But with a wedge, it points the other way. So you've got to take your latitude off 90 degrees and set your wedge at that. So it would be set at 35 degrees for our latitude for a wedge.
Yeah.
It's difficult getting your head around that. But yes, I built one when I was in my teens. But I wasn't doing photography then. It was just so that I could put a clockwork motor on my Altaz mount to push it around to track the stars. And those wedges were great for visual. They will keep the object that you're looking at in the field of view quite happily, but they tend not to be accurate enough for taking a picture, because it has to be deadly accurate and keep the object absolutely perfectly still in the picture.
Yeah, cool. Okay, great. So that's it, I think, in terms of questions. I have posted the code for the Move Shoot Move rotator in there. I do like that. I've used it at the minute just for time lapses and movement. I haven't got it pointed to the sky yet.
It goes over the Star Adventure. It allows it can control your camera, so it will take an image and then wait a bit. It'll continue to track, and it'll take another image and wait a bit.
That's what the MSN does, which is quite clever as well. But someone has basically said thank you, which is great, and has said, though, do we do tracker tuition at the observatory once we're allowed to be people again? And the answer to that is yes. If you go to the Battlesteads Observatory website, Chris does run full day, and actually sometimes even overnight full day residential stays for astrophotography, where you can bring your equipment or look at Chris's equipment and get really stuck into it. Yeah. And if you've got
also invite people who are coming for a night astronomy, if they've got a telescope and they're struggling with it, we just say bring it with you and we'll show you how it works.
That's true. I mean, we do that. I think most of the observatories, I think we all do that. If you bring a telescope to one of our observatories, whether it be Kielder, whether it be us, Twice Brood or Stonehoff, you're going to get help. We're all really friendly, lovely, helpful, professional people, so you'll get help there. Fabio, Chris, has just said, oh my God, that is what I've been doing wrong with my EQ wedge, exclamation mark, exclamation mark, exclamation mark. So I don't think Fabio realised that they had to do the reduction.
Well, they point the other way because
they point the other way, Fabio. They point the other way. Come on.
It's on an Altaz mount's like on a fork rather than that kind of thing. Yeah.
Well, listen, Chris, we need a break and we need to start the next stream. So the masterclass will not be on this stream. The stream's now going to end and it will be kept on our channel. So if any of you want to come back and rewatch it, you're welcome to do that. Thank you all for joining. Thank you, Chris. And we will see you in 20 minutes or so on the masterclass stream, which I have posted.
Do not be put off by the word masterclass. It's going to be fairly straightforward.
Honestly, just all of there was two. Just all come along to the masterclass, because even if you want to keep asking newbie questions or so on, or if there's anything that you missed in this presentation that you want to go over, then we're going to do that. Chris has got a little bit of a presentation, do a shorter, a little bit more in-depth top tip presentation to do, and then we're going to have loads of questions. Okay, so see you in about 20 minutes on that one. Thanks a lot, everybody.
Bye.
And bye-bye.